Greetings and salutations and welcome to the Inventor video. In today's video we'll be doing part 3 of the Inventor ACU guide. So as you can see here, go down to the ACU and here are all the exam objectives. In the past episodes we've done part modelling, sketching and browser editing, and in this video we're going to be going over assembly modelling and we might delve into user interface and navigation. So let's get into it. So you see we've got Inventor. I've just prepped a little bit of just some basic kind of solids you can use in assemblies, because to actually have an assembly you need to have parts. Yes, you can create parts in an assembly environment, but just having some parts prepped just saved me modelling it, and they're pretty basic. So you see I've got a C channel here that I've just put a hole in for an axle. Pretty basic. I've got a keyed axle here. The square like nut in the middle is just purely for reference, because it's not always easy and obvious to see that that's completely like if it's moving, whereas the square makes it abundantly obvious. And then you see I've just got a block which has got a round edge, it's got plenty of other size round edge to show tangential constraints, but that's pretty much all the prep I've done outside of videos. So if you want to replicate it, measurements aren't really exact, this is more just to show you how to do it. So assembly modelling, apply basic constraints, mate, flush, insert and directed angle. So if we go in, the first thing you need to do is bring up the assembly environment. There we go. And you're going to need to place some parts in. So if we start with, let's start with the C channel, because that's probably, as you see it's going to drag it in, and if I then just spin it on X, that can now just bring it into us, and that's on the front. And you can just click OK to stop placing that part. You can place it multiple times once you've like bringing it in, and there you go. Now the first thing you kind of really want to do, which is really later on in the list, is we're actually going to ground the base component. This basically gets rid of all of its degrees of freedom. Degrees of freedom is how it can move. So you have X, Y and Z, X spin, Y spin and Z spin. And so you see if I just go here and ground it, so you just click right click grounded, and you see it gets this like little tack pin up there, which means you can't move it, it's completely solid in place. As you see, we can just look at it, it's pretty boring, so let's bring in some more. So if we then just place in, we can place, let's go for the keyed axle. So as you can see, it's kind of the wrong orientation. Now if you see we've got the X, Y and Z, we want to rotate it along the axis that's going to get us into that position, which is Z, because you got to remember you got to spin it around Z will lead us to it being horizontal to us. Where you put it Y, it's just going to spin it around the Y, so the square will only really change to the keyed part, and if you do it around X it will just like be a bar with a square on it. So if we just do rotate Z, there we go. And so there we are, we now have two components, and they now kind of, well, they don't really do a lot. They can kind of phase in and out each other, but that's kind of modelling for you. So now what you can now do is you can now apply some constraints. So you've got your constraints all up here. We're mostly going to be focusing on mate, angle, tangent, or not even tangent, mate, flush, insert, direct angle. So you got mate, flush, directed angle, and insert. Tangent we can go into later, I'll throw it in a bit of a bonus. Symmetry won't even bother with. So really for these two we're going to focus, we can do this constraint actually in multiple ways. So if we start with actually just doing it in mate, so you just select it here, it's selected the axis that goes through it, and you can select your if you select the ball here, the hole will actually go through the axis, and there you go, you hear a little click and it's then put it into there. Click apply. And so if you see what's happened now, is now it can only travel along there, but it's not really that useful because it can still move around. And to stop that from happening, what we can really do is if we throw that out a bit more, constrain, and just allow it to go around, and we can then just set this one to be flush. So you see it's now flat. So you can now see we've now got it in there, and you can see it spins around still, and we can kind of solve this one pretty easily. So you see the little key part here. We're going to constrain. And we can just click one of those, click any really of those sides, and you can then just click the base there, and we'd set it to angle. So there you go, 0 degrees. And now obviously you can apply offsets, so like 90, 180. I'm just going to set it to 0. The main reason you would use like an angle is either to specifically fix something like that, or the better thing I find the angle most useful for is if you select drive, what you can now do is, if I say 720, is you can actually drive the axle around. So you can see it now rotates around. Obviously it's lagging slightly because of recording, but so I'll stop that. But obviously you can drive the axle in the shaft. And so that's really mostly on the mate and angle. The next one we need to actually go into is, let's bring in some more parts. Let's place it in our block. There we go, block. So you see we've got a block here. Click OK. Constrain. You can essentially just select those two to face up like that. Click apply. And you could essentially, if you wanted to bring them more in line to each other. There you go. So now they both share a common plane and they're both joined to each other. Well, constrained is the better term. So you see they can slide up and down. They can't move. They can't move in each other. They can't move to the sides. They're perfectly constrained there. But you can see what we can also do is, if we go into this mate one here, I can apply an offset. So if you wanted to put a gap in there, you say 5 mils, you can bring them further, closer and further apart. And so you see there, so you now see we've done some basic constraints. We've grounded, I showed you earlier, applied an offset. The last couple of things: determine the degree of freedom and create a presentation model. Oh, and an insert basic constraint. So an insert basic constraint is pretty much very similar to what I did at the start here. So if we just delete these constraints out here, so you see we've got the axle out. Constraint, insert, and now you see what we can do is you can now line up both of them, and it does very similar, except you can now then choose to oppose or align them. And if you notice, they've got like little directional arrows little right here, so they can either be opposed, etc. But you see, overall, the other thing you get with an insert is you're also allowed to lock the rotation, but you can do that with an angle constraint, but it allows you just to do a 2-in-1. So you can click apply, and then obviously I can then bring in another constraint here and here, constraint. That might be actually. Okay, right. So I think the other opportunity we've got here to also show you is the degrees of freedom, which obviously I must have mixed up there. So if we go into keyed axle and you go into iProperties, go into occurrence, and you see this little degrees of freedom, click check and apply, and now you can see everything. So it's got its X, it's got its Y, and it's got all of its rotation. And so you can then constrain, insert that through there, click apply, and so now you can actually see it's only got its rotation. So an insert constraint really does just get rid of everything apart from that, which is the main kind of, it's an advantage and a disadvantage. So you just got to choose your constraints wisely is the main kind of thing. But you can see I generally prefer mating. I generally prefer the mating because it gives you a bit more flexibility. But obviously you don't always want flexibility because that's the point of a constraint. Okay, and last but not least, we are moving into create a presentation model, which is dead simple. Click on the assembly v2, create a presentation. There's going to say save it. So if I just click video assembly 1. Standard IPN. And that just brings you into it. Like, perfect. And that is it. Thank you for listening and see you in the next video. Goodbye.